Hello, everyone, and welcome back to your favorite channel. This is Maths Zone African Motives, and today we want to look into grade core physical sciences. We want to start looking into grade core physical sciences. So, what we are going to do is we are going to start with topics that were also done in grade 11 as we combine both grade 11 and grade 12. So today we are going to start with a topic that you refer to as forces and Newton's laws. Forces and Newton's laws. So what we are going to be looking into, we are going to look into the types of forces, Newton's laws of motion, free body diagrams, and the applications in gravitation. So what is going to happen is we are going to look into a bit of some revision because this topic was done in grade 11 in depth. So for us to catch up, because this is also examinable in your grade 12, examinations, we need to actually get to look into the principles that we looked in grade what? In grade 11. So without wasting time, let's start by looking into type of forces and then get into definitions. So we are going to start by defining what we refer to as a force. Actually, before we start, I want to ask a question. What is it that we refer to as a force? What is it that you can define as a force? When you hear the word force, what is it that comes into your mind? So, what we refer to as a force, it's either a push that you can apply maybe to an object or a box, or else a pull. When you push a box, you are applying a force. When you pull a box, you are also applying a force. So we are going to actually get to adopt this definition, where we are going to say a force is a push or a pull that is resulting from interaction between objects. So if you yourself, you get to apply a force, which is to say, if you get to push a box, you are applying a force. When you get to pull a box, you are also applying a what? You are also applying a force. So this is what we term a force. A force is either a push or a pull that results from what? From interaction of what? Of bodies, or else interaction in between two or more objects. So a force can actually come with different effects. It can either cause an object to speed up. Maybe an object was already moving. When you apply a force, that is, if you push that object that was already moving, it can actually increase its speed. At some point in time, if you actually apply an opposing force, it can actually get to what? To reduce its speed. So that is one of the effects of a force, where we are saying that a force can either change the speed of an object. Also, a force can actually change the direction of an object. Let's say that an object was moving towards the right. When you apply a force that is towards the left, and that force is greater than the effect of this moving object, it will cause this object to change its direction and start moving to the what? To the left. Or else, let's say that you hit a ball that was coming towards you, towards the left. Let's say maybe you're playing tennis and you use a racket to hit a ball. That ball will change its direction from moving to the left and start moving to the what? To the right. So that is also another effect of what? That is also another effect of a force. So we are saying that a force can either increase the speed of an object, or else it will change the direction of the object. Also, you can also get to see that, let's say that when you are having that racket of yours, and then you get to hit a ball, and that ball is not a tennis ball, or else let's say that you hit, yes, a flaccid ball, you can either change its shape, it can either deform, or else burst. So that deformation is what we are referring to as the what? As the change in the shape of that object. Also, when we have got two objects, the other one moving towards the right, whilst the other one is moving towards the left, and then these two objects, they come to where they collide, you would actually get to see that the other object that was moving maybe at a slower speed than the other one that is carrying a higher momentum due to its higher speed, it will actually get to deform as it crashes on the other object. So that change in shape, or else the deformation, is what we are referring to as what? One of the effects of a force. So we are saying that a force can either change speed, change direction, or else change shape of an object. Also, as we are referring to the speed, we can also see that a force can either cause an object to start or else to stop motion. So if you are having an object that is at rest and you apply a greater force, that object can actually start moving. So that is what? Starting its motion. And then if you are also having an object that is already in its motion, let's say you slide an object and then maybe it's a box, that object actually comes to rest at a certain point in time. What causes this object to stop is what we are referring to as what? As a force. It's a type of force. So that is also an effect of a what? Of a force. So already we have defined 4 effects of a force. So a question will come into your exams and it will ask you to name or state either 4 or 3 effects of a force. You can either choose to say that a force will change the speed of a what? Of an object. It can also change the direction of that object. It can also change the shape, as well as it can cause an object to start moving, or else it can cause an object to what? To stop moving. And then we measure our force in newtons. So the units of a force is what we refer to as what? As newtons. The unit of a force is what we refer to as newtons. Now we want to dive deep into looking into different types of forces. So you are going to see that we have got different types of forces that exist in our world. But within our syllabus, we are going to be looking into a type of force that we refer to as the weight of an object, or else the gravitational force. And then we are also going to look into a type of force that we refer to as the normal force. So a normal force is just the perpendicular force that is applied by a surface to an object. And then we are also going to look into what we refer to as the frictional force. And the frictional force is just an opposing force of motion. Mind you, we are going to dive deep into defining what weight is, what normal force is, what frictional force is, as well as what a tension or tensional force is, and an applied force is. And look into how we measure them, how we determine them, and how we actually get to identify them, how we represent them in terms of force and free body diagrams. So here we are just mentioning or else stating the different and common types of forces that we are going to be looking into within our what? Within our syllabus. So these are the types of forces, which is your weight, that we term the gravitational force, the normal force, which is your perpendicular force applied by a surface, frictional force, which is the opposing force of motion, your tension, which is usually a force that you will actually get to see or else that exist within ropes or else strings, and then an applied force. So as we look into this picture diagram that I have here, I just took this diagram from a certain textbook for representation purposes, so that at least you can get to have an idea of what we are talking about. So from this diagram, you can see that this is our normal force. It is usually directed towards up. At some point in time, it can be directed towards a slanting motion. It depends. It depends with how the object is oriented. And then when it comes to weight, our gravitational force is always directed downwards. And then we have got our friction. Our friction is usually due to the roughness of the surface. That is to say, the opposing force of motion, it is usually due to the type of what? Of surface that we are having in which our object is moving. And then we have got an applied force that is also usually due to the direction in which our force is being applied. It can either be inclined towards a certain angle, it can be horizontal, it can be vertical. It will depend with how that application is being done. So now let's look into individual type of forces. So we have what we refer to as the normal force. We say that the normal force, it is the support force that is exerted by the what? By the surface on an object that is resting on it. So if you actually get to, let's say you put a book on a table, you will see that that book will not sink on that table. Why is it that that book is not sinking on the table? It is because we have what we refer to as the normal balancing force that is due to that table. So the normal force is that perpendicular force or the support force that is exerted by a surface. Pardon me, at some point in time, you might hear some background noise that is due to some rain. It is raining where I am. So when we are looking into normal force, like I said, the normal force will depend on the orientation of our object. Like for example, here, a book is just resting on an object. A book is just resting on our table. So our normal force will just act perpendicular to that book. That is to say, it will be directed upwards. And then here we can see that our table has been lifted and it is now slanted. So you can see that there is a certain incline. So you will see that the normal force will act towards an incline towards that what? Towards that table. So this incline would be balanced by a certain force so that this book does not spin. So we are saying that the normal force depends on the what? It depends on the orientation of our object, on our what? On our surface that is supporting it. Now let's look into what we refer to as the what? As the gravitational force. What we refer to as the gravitational force is usually what we refer to as the weight of an object. Some scientists, they define this force as the gravitational pull towards the center of the earth. This is the force which is applied by the earth, which is to say it is either the gravitational pull or push that is towards the center of the what? Of the earth. So you will see that this force is defined as the force of attraction between masses where we have got two masses, these two masses, they tend to attract each other. That force of attraction between the two masses is what we refer to as what? As the gravitational force. So this force is usually defined in according to Newton's universal gravitational law. We shall dive deep into that law as we go, but for now we just need to know that a gravitational force is what causes objects to fall. What causes our objects to fall? Let's say you are at a certain height, maybe you are on top of a building, and then when you are on that top of a building, you are holding maybe, let's get to say, a ball, and you release it. What causes that ball to fall from that top of a building is what we refer to as the what? As the gravitational force. And also, taking for example, let's say that you are maybe in a river, in a dam, or else in a sea. You are sailing in a river or else in a dam. And then maybe at some point in time, that boat of yours, it capsizes. You would see that you can start to sink within that dam. So what causes you to sink, or else what causes objects to sink in water, is what we refer to as the what? As the gravitational force. So your gravitational force, it depends on the mass of an object. Why is that so? Because we define the gravitational force with a certain law which says that our gravitational force, which we refer to as our weight, which we can represent by Fg or else by W, is defined by the mass of an object times the gravitational acceleration. Gravitational acceleration of the object. Gravitational acceleration of the object, which is represented by G. So we usually define our weight or else our gravitational force by a law which says Fg or else W is equal to mg. And it is always directed downwards. It is always directed vertically downwards. So you will always see your gravitational force being directed downwards. So from this diagram, from this picture diagram that I brought here, is just a diagram that I wanted to represent your normal force that you have already talked about, that will be applied by this surface on this box that is seated, or else on this object that is seated on this horizontal surface. So you'll be having your normal force that will be directed upwards. So what will be balancing this normal force? It will be the gravitational force, which is the force due to the gravitational pull towards the center of the what? Of the earth. So these are the two types of forces that we have defined so far. Now let's go ahead and define what we refer to as a friction, or else what we refer to as frictional forces. Frictional forces. What is it that we refer to as frictional forces? So before we go into frictional forces, I would like to ask a question. Why does a box that maybe you might slide on a surface eventually come to a stop? Or else, let's say you slide a ball. I'm sure for those who have gone maybe at some point in time to some bowling clubs, you roll a ball, and then that ball, it actually what? Slides towards some objects that you will be actually trying to hit there. So now I'll take that motion of sliding a ball. Why is it that if you slide a ball, let's say in your house, it will eventually come to a stop? So the answer to that question is friction. What causes object to eventually come to a stop when they are sliding on surface is what we refer to as friction. So what we are referring to as a frictional force, this is the opposing force of motion. whatsoever opposes the force of motion, whatsoever opposes the force of motion is what we refer to as friction. So you can actually define your frictional force as the what? As the opposing force of motion. Opposing force of motion. Whatsoever opposes the force of motion, whatsoever opposes anything that you want to move, whatsoever opposes what is moving, whatsoever opposes any force that wants to cause movement is what we refer to as your frictional force. So the definition that we are going to adopt here is that the frictional force is a force that opposes motion or attempted motion between two surfaces in contact. So a force that opposes motion or attempted motion between two surfaces in contact is what we are going to term as what? As friction. For example, you have got a box that is resting on top of a table, which is rough on its top. We have got an applied force. This applied force will try to cause movement within this box. It has to move sliding past this rough table, but because of the roughness of the table, we are going to have some resistance. That resistance is what we are going to refer to as what? As frictional force. As frictional force. So the magnitude of the frictional force will depend on the surface, which is to say on the roughness of the surface. The rougher the surface, the more the frictional force. And you do also depend on the magnitude of the normal force. So you will see that our frictional force will be defined as mu times the what? The normal force. So this mu is what we refer to as the what? As the coefficient of friction. Mu coming from the Greek word mu, mu. So from that Greek word mu, that is where we adopted this coefficient of what? Of friction. So that is what we term frictional force. And we've got two different types of frictional forces. We've got what we refer to as the static frictional force. This is the force that prevents any movement. When you have got an object that is at rest or else that is resting, and then you try to apply a force that you want to cause movement, and then whatsoever is causing resistance to motion, or else that whatsoever that is preventing this object to move from that resting position is what we call static friction. Static coming from the word stationary. We adopted this definition from what? From stationary object. Whatsoever is causing our object to be at stationary is what we refer to as what? Static friction. The static friction is what prevents motion. So static friction can be adjusted from a minimum to a maximum value, which we will actually get to call what? Fs. And that maximum value can actually be equal to what? To mu s times n, where n is referring to normal force and mu s is referring to the what? To the coefficient of what? Of static friction. So we are going to see that whenever we have got an object at rest and then we apply a force, at some point in time you might apply a smaller force trying to move this object, and you see that this object will resist that motion. And then you try to increase or else to apply a greater force, and also they will be resistant to motion. And then you later apply a greater force that will cause this object to start moving. So what you certainly see is that initially when you applied F1, which was a smaller force, you were having Fs, which is a minimum what? Static frictional force. When you applied F2, which is greater than F1, when you applied F2, which is greater than F1, you were now having at least a certain magnitude of what? of static frictional force that opposed that F2. So at some point in time, you would see that Fs would be greater than F2. So you can see that our static frictional force is increasing as we increase our applied force. When you now apply a greater force that is greater than F2 and F1, that's when now you start seeing some movement, which means that now we have actually reached our maximum static frictional force. Therefore, our applied force F3 is now greater than our maximum reachable what? Static frictional force due to the roughness of the surface as well as the normal force. Hence, therefore, I would like to use a diagram that I adopted from a certain textbook that you use on your grade 12 syllabus, which is drawn here. This diagram depicts our frictional force on our y-axis and then our applied force on our x-axis. What it is actually showing us is that as you apply your applied force, or else as your applied force is increasing, as you go to your what to your more positive x-axis, you would see that the magnitude of the static frictional force is increasing to a certain maximum value that is corresponding to an applied force of what? Of 3 Newton. So here, this is where we would have also reached our maximum value of our static what? Frictional force. So you can see that at 3 Newton of applied force, we are also having a corresponding 3 Newton of our what? Of our maximum static frictional force. As we go beyond this 3 Newton of applied force, now the box or else the object will now start moving, which shows that we have now overcome what we refer to as the maximum static frictional force. Once we overcome that maximum static frictional force, now as the box is sliding, we are going to have a minimum opposing force of motion, which we refer to as the kinetic frictional force. This is where we are now having a jump from a greater maximum static frictional force to a minimum static frictional force. And this minimum static frictional force is going to remain constant because now our object is what? Is in motion. So the second type of what? Of frictional force is what we term kinetic frictional force. This comes into play wherever we have got moving objects. Wherever you have got a moving object, you are always going to have what? You are always going to have what we refer to as kinetic sliding frictional force. That comes into play wherever an object is in motion. This is also due to the roughness of the surface as well as the normal what? As the normal force. So you are going to have what we refer to as the what? As the coefficient of kinetic frictional force and the normal force. That is what is going to define our kinetic frictional force. Once we know that, we now know that we now have what? We now know that we now have got two types of frictional forces. I would like you to remember this diagram very well and the explanation that I gave, where I said wherever we have got an object at rest and we want to cause this object to move, we are going to apply a certain force. That force can be a minimum. In that force, it will actually face a resisting opposing force of motion that would also be at a minimum. So, as we increase the applied force, as we are trying to overcome this static frictional force, the static frictional force will also increase as we increase our applied force. As this applied force is also increasing, as we are increasing the applied force, the static frictional force will also increase, but it will reach at a certain maximum value. When it reaches that certain maximum value, this value is corresponding to the applied force that we would have applied, which might be equal to a certain magnitude, which here is corresponding to 3 Newton. So it simply means that our maximum static frictional force would be equivalent to 3 Newton. Once we go past that 3 Newton, it certainly means that we have overcome the static frictional force. Hence, therefore, this box of ours will start to move. As it starts to move, when it is now in motion, this static frictional force, or else the maximum frictional force that we would have reached, it will now actually get to what? To jump to a smaller kinetic frictional force, or else it will fall to a smaller kinetic frictional force, because now we are now having little resistance to our motion. The object is already in motion, so the resistance that we are having, it's actually what? Small. Even if you apply a smaller force to that moving object, it will certainly increase in its speed. It will accelerate because it is already in motion. Therefore, we tend to say that the kinetic frictional force is at a minimum. So a question will come into exam and it will say, describe the relationship between static frictional force and applied force. Use a diagram to depict that explanation, or else use a diagram to support your answer. This is the diagram that you give, and you give the explanation that I've just given right now. Now allow me to move forward to another type of force that we are going to be looking into, which we term tensional force. Now, what we refer to as a tensional force, this is the type of pulling force that you always find, or else that exist in strings, ropes, or else chains, or cables, or rods, or struts, which are under pulling forces. Wherever you have got an object and there is a rope or a string or else a chain that is being used to pull this object, we are always going to have tensional force within this rope. So within this rope, this is where that force is going to exist. Within this string, this is where that force is going to exist. Within this chain, this is where that force is going to exist. So the definition of the tensional force that we are going to adopt is termed as a tension, or a tensional force is the magnitude of the pulling force that exists in the objects such as ropes, strings, chains, cables, or rods, as well as struts. When we refer to as struts, these are, let me get to say, these are planks that you use to support your roofs. So within that struts, you are going to also have what we call, or else what we refer to as what? As tensional force. So a tension, or else a tensional force, acts along the length of the rope or cable, and it pulls away from the object on both ends. So let's say, for example, I've got my roof, and then within this roof, I get to suspend a certain object. Let me say a doll. Let's say, at some point in time when we are playing with kids, or else you do not want maybe your young sister, or else your little sibling not to disturb you, you might actually get to suspend a doll from maybe, let's say, the top of the roof, so that that doll will be actually moving, just playing around. And as your little sibling is watching that doll playing around, he or she would just be entertained in such a way that he or she doesn't get to disturb you. So we are saying that that rope that is suspending that doll on that what? On that rooftop, would be having what we refer to as the tensional force. So that tensional force would actually be pulling away from the roof, as well as pulling away from the what? It will be also pulling away from the suspended doll. So you will see that that tensional force, it actually exists in between this rope, in between these two objects. The doll that is suspended, the tensional force is pulling away from that doll. And then the roof in which that doll is suspended from, the tensional force is also pulling away from it. So we say that the tensional force acts along the length of the rope or cable, and it pulls away from the object on both ends. So you can see that you can represent this tensional force with these two arrows. But usually, when you have an object that is suspended, you always have your tensional force pulling away from the object, so that this tensional force will be balanced by what we refer to as the weight of an object. So this is how, whenever they say draw a force diagram or else a free body diagram, you would actually get to adopt your representation of the tensional force as well as the weight of the object. Now let's go to another type of force that we have here, and usually this becomes our last type of force that we are going to be looking into in our syllabus, and we refer this as the net resultant force. It's either represented as F net or F resultant. From our grade 10 and 11, we've been looking into vectors, and then in grade 11 we looked more into sum of vectors. So this is the same principle that we are going to use in defining our net resultant force, where we are going to say a net resultant force is defined as the vector sum of all forces acting on an object. The vector sum meaning to say that the sum of individual vectors that are acting on that same object. That is what we refer to as as the vector sum of all forces acting on an object. So that is what we refer to as as the net resultant force. So whenever you have got forces that are acting in the same direction, let's say I've got F1, which is the pushing force, and F2, which is the pulling force, and they are all directed in the same direction. Whenever I'm looking for the net resultant force, I have to add these two forces. So I will say F1 plus F2. But wherever I have got forces that are acting in different direction, let's say F1 is pushing in towards the right, and F2 maybe it is your frictional force that is opposing, that is in the left direction. Now whenever you are looking for your net resultant force, you have to subtract. So it might be F1 minus FR, where now you need to first choose the positive direction. Either you are saying that going to the right is positive, or else going to the left is positive. So that is how we determine and define the net resultant force. So take this representation here to mean F net to be equal to F resultant, being the sum of all vectors of all vector sum of forces. So you will see that according to Newton's law, without diving deep, we have got a formula that defines our net resultant force, which says F net is equal to ma, where we have got our mass and our acceleration. Therefore, it means that when we have got acceleration being equal to 0, our F net will also be equal to 0. And then whenever the object has got some acceleration where the acceleration is not equal to 0, it simply means that our net force is also not equal to 0. So after we have said that, we have defined the common types of forces that we are going to be looking into. We now want to start looking into the Newton's laws of motion, because the definitions that we have given now and the Newton's laws of motion that we are going to look into, they are going to help us in attempting to solve and determine different types of what? Of magnitudes or forces that will be acting on our object. So we'll be given different scenarios and they will say determine the net resultant force, determine the tension, determine the applied force, determine your weight or else your normal force or the frictional force acting on a certain object. For example, they will say we have got an object that is resting on a horizontal rough surface. Determine the frictional force that is acting on that object if the applied force maybe is equal to a certain magnitude and the net resultant force is equal to, or else you know your acceleration of the object. They tell you that the acceleration of the object is equal to 2 meters per square second. And then now they say determine the frictional force given the applied force being equal to 10 Newton. And now, because of the weight of the object, maybe they say the mass of the object is equal to what? To 10 kgs. You can calculate the what? The net resultant force from the applied force and the what? And the gravitational force. And definitely you can calculate your what? Your resultant frictional force. So these are the scenarios that you would want to define after we have defined the Newton's laws of motion. So allow me to actually get to what? To start diving deep into the what? Into the Newton's laws of motion in the next coming video. Thank you.